Hello, welcome back to fractional calculus class. Today we'll be checking Laplace transform of Caputo fractional derivative. So in our previous videos, we checked the Laplace transform of Riemann-Liouville integral, which is a Laplace transform of integral 0 to x of alpha f of x, and is given as s minus alpha f of x. So and also we also take note that the Laplace transform of derivative, which is f of n g of x, f of n of x, which is the same thing as Laplace transformation of derivative of x, is given as x n of f of x minus summation k equals to 0, n minus 1, and x k f of n minus k minus 0 minus 1 of 0. So this also, we can also write it as xn f of x minus summation k equals to 0, n minus 1 s. Then we have n minus k minus 1 s, f of k of 0. Now by the time we expand this, we have xn f of x minus at k equals to 0. We're going to have x n minus 1 f of 0. At k equals to 1, we have x n minus 2 f prime is 0 dot, which is still the same thing as our Laplace transform of f of n of x, and then the Laplace transform of differentiation derivative. But we'll be going by this for Laplace transformation of Caputo fractional derivative. So having all this, then we can now go to the main object of this video. So the Laplace transform of Caputo fractional derivative. Now this is the same thing as Laplace transformation of first integral is 0 to x n minus alpha, then the derivative here over the xn of the given function f of x. So that the slight difference between Riemann and Caputo is that you integrate you differentiate first before integration, while in Riemann-Liouville you differentiate first before you integrate first before the differentiation. All right, so let's take the whole of this to be g of x. Let g of x equals to dn over the xn of f of x. So by then we are going to have Laplace transformation of integral is 0 to x n minus alpha, then g of x. Then following by the Laplace transformation of this first, we are going to have x square minus alpha, x square minus or what we have here, which is n minus alpha. Then we have function of x. So here our function of x, which is g of x, our function of x is a Laplace transformation of g of x, and that is the Laplace transformation of derivative of f of x, which is equals to, I come back to this and make use of this, which is xn of x, xn f of x minus summation k equals to 0, n minus 1, Sn minus k minus 1, then f of k of 0. So we substitute this here. So we have x minus s minus k. So f of x now is xn f of, so it is f of x minus summation k equals to 0, n minus 1, Sn minus k minus 1, f of k, then 0. So we use this to open the brackets. So we have x, this time it will be x n minus n plus alpha, and you open this, you have that. Then we have f of x minus summation k equals to 0, n minus 1, x, then also we use this to open this. Also we have x n minus k minus 1 minus n plus alpha, and f of k is 0. So this cancel this, then we are left with x is power alpha f of x minus summation k equals to 0, n minus 1. So this cancel this also. We have x alpha minus k minus 1 f of k, then is 0. So this is Laplace transformation of Caputo fractional derivative. Alright, so here we stop in our Laplace transformation. Then in the next video we will consider other fractional derivative. Thank you for watching. My name is Ndundu. See you in the next video.